Hello everyone, welcome to Lecture 1 of the GMP and Quality Fundamentals series. In this course, I want to explain GMP and quality in the way that they actually work in industry. Not like a dry university lecture, but also not superficial. We'll combine academic definitions with real industrial examples, so these concepts really stick in your mind. Why does quality even exist? Different companies produce different products. Some make medicines, some cosmetics, some food and beverages. All of them must be tested and controlled. To make things easier, let's use a simple example, a cake. We will look at the cake at home and the cake in a company. Before talking about systems, let's ask one simple question. Why does quality even exist? The honest answer is, because people can get harmed. Most quality regulations were written after accidents. For example, someone got sick. Someone was seriously injured. And then rules were created. Quality systems exist to protect people. And that's something we should never forget. What is GMP? GMP stands for Good Manufacturing Practice. Academically, GMP is a system of guidelines that ensures products are consistently produced and controlled according to defined quality standards. In simple words, GMP means working in a controlled, repeatable, and documented way. Imagine cooking at home. If every time you cook you wash your hands, clean your tools, use the same recipe, and write down what you did, that's already GMP thinking. In industry, GMP covers personnel, facilities, equipment, documentation, raw materials, and processes. The key idea is simple. Quality must be built into the process, not tested only at the end. Now imagine a company producing thousands of cakes every day. Here, GMP means clean rooms, trained personnel, documented recipes, controlled temperatures. What is quality control, QC? Quality control is the testing part of quality. Academically, QC includes analytical and microbiological testing used to verify whether a product meets predefined specifications. In practice, QC works in laboratories. QC takes a representative sample and tests identity, purity, heavy metals, pesticides, and microbiology. QC answers a very simple but critical question. Does this product pass or fail? For example, quality control takes samples of the cake. QC checks. Is the weight correct? Is it microbiologically safe? Are the ingredients within specification? QC reacts after the cake is produced. What is quality assurance, QA? Quality assurance is system-oriented. Academically, QA is defined as all activities that ensure quality requirements will be fulfilled. In real life, QA focuses on SOPs, training, deviations, CAPA, audits, and supplier qualification. Now you might ask, what is CAPA? CAPA equals corrective and preventive action. Imagine QC finds mold on a cake. Corrective action. Throw away the affected cakes. Preventive action. Fix humidity control, retrain staff, improve cleaning. CAPA fixes both the problem and the cause of the problem. If QC finds a problem, QA investigates the root cause and improves the system so the problem does not happen again. Quality assurance looks at the whole process. In our cake example, QA asks, was the oven calibrated? Was the recipe followed? Was the staff trained? QA tries to prevent problems before the cake is even baked. QC versus QA mental model. A simple way to remember this. QC finds problems. QA prevents problems. QC is reactive. QA is proactive. Reactive means reacting after something happens. Proactive means acting before something goes wrong. QC reacts when the cake is already baked. QA acts before baking starts. QC works mainly with samples and results. QA works with systems and processes. What is regulatory affairs, RA? Regulatory affairs ensures compliance with laws and regulations. Academically, RA manages the interface between the company and regulatory authorities. In practice, RA checks whether a product can legally be sold in a specific market and whether label claims are allowed. A product can be technically perfect, But without RA, it might still be illegal. Now let's look at regulatory affairs using the cake example. RA asks, are we allowed to sell this cake? RA checks things like, are all ingredients legally allowed? Are allergens correctly labeled? Are nutritional claims permitted? For example, if the company wants to label the cake as high protein or sugar-free, RA checks whether this claim is legally correct. The cake might taste perfect and pass all lab tests, but without RA approval, it cannot be sold. RA makes sure the product is not only good, but also legal. What is research and development R&D? Research and development is where innovation starts. Academically, R&D focuses on developing new products, improving formulations, and testing feasibility. In practice, R&D asks questions like, can we make this product cleaner? Can we reduce contaminants? Can we improve stability or performance? R&D works closely with QC, QA, and RA to ensure products are innovative, safe, and compliant. Now let's talk about R&D using the cake example. R&D is where the cake idea is created. R&D asks questions like, what kind of cake do we want? Chocolate or vanilla? Sugar-free or high-protein? Long shelf life or fresh product? R&D tests different recipes, ingredients, and baking conditions. Maybe they try to reduce sugar, replace ingredients, or improve taste and texture. Once R&D finds a recipe that works, it is transferred to production, and then QC, QA, and RA take over. R&D is about innovation and feasibility. Documentation, the silent hero. One very important GMP rule is this. If it's not documented, it didn't happen. You can do the right thing, but without documentation, it does not exist in GMP. That's why documentation is the backbone of quality systems. Quality is not only a lab job. Many people think quality is only about lab testing, but that's not true. You can have perfect lab results, but poor documentation, missing training, or wrong labeling, and still fail GMP. Quality should be everywhere. How everything works together. Think of quality as a chain. R&D creates the idea. QC tests materials and products. QA controls the system. RA ensures legal compliance. GMP is the framework connecting all these functions. Quality means decision-making. Quality is not only about testing, it's about decisions. Do we release the batch? Do we reject it? Do we investigate further? Quality professionals must be comfortable to making uncomfortable decisions. Quality is also about communication. Quality is not only technical. You need to explain results to R&D, production, and management. If you cannot communicate quality, you cannot protect quality. Why this matters? These concepts are the foundation of careers in QA, QC, GMP, and regulatory roles. They protect consumers, ensure product safety, and build long-term trust in brands. So if we look at the cake example as a whole, R&D creates the recipe. QC tests the cake. QA controls the process. RA checks the law. GMP connects everything. I'm creating this series to share my own understanding of GMP and quality, and what I learn along the way. In the next lecture, we will dive deeper into GMP principles and documentation, including SOPs, batch records, and deviations. If you're interested in GMP and quality systems, stay tuned for the next lecture.